I mean, just by the very
Sorry.
very nature of a magneto, they rob you probably of a couple of horsepower of actual horsepower on the engine because you're trying to move a fairly large mass. To go to the next level, or to look at what we should be doing for the next thing for ignition systems, our engineering approach has always been to move into high performance ignition system, much like the automotive industry did in the mid 80s when we got rid of leaded fuel. There's a little forecasting there for what might be coming down the future. Scott, go ahead and hit the next slide. So high performance ignitions, or can I? No, I can't do that. So high performance ignition systems need two things. They need high energy, and they need the ability to vary timing. Go ahead and hit the next slide. Our system does both of those things. We have very high energy coils. As most of you, I'm sure, familiar, our coil pack system, which mounts on the firewall, generally speaking, mounts on the firewall. Those coils put out about 70,000 volts through 20 degrees of crank rotation. A magneto on its best day during normal cruise is going to put out about 12,000 volts through just under 5 degrees of crank rotation. During the start sequence or during low RPM operation, as it's a generator, it's going to put out even less energy from the coils. If you want to talk about it in terms of joules, we put out 9 joules of energy. A magneto puts out anywhere between 27 and, I think the slick guy told me this year, 40 millijoules of energy.
Come on, Sass.
So we have high energy coils, and then we also have variable timing that we do based around manifold pressure. Our manifold pressure circuitry is very simple. We advance timing 2 degrees of advance for every inch below 24 inches of manifold pressure. So when the engine is above 24 inches of manifold pressure, we're at fixed timing. Most of these engines, I think, are at 23 degrees placarded. Actually, in the kits now, we do for the 182 RGs, we send them out at 22 degrees before top dead center, and I'll explain that later when we get a chance to it. But in any event, the Electroair system does both. We have high energy coils and we have variable timing. Scott, you can hit this slide, next slide, and move through it pretty quick. So when you're doing this, go on to the next slide. Typically, this is what you see for a normally aspirated airplane. Normally aspirated 6-cylinder airplane, typically 1.5 gallons, 2 gallons per hour fuel savings. We have seen airspeed increases. I didn't have a chance, one of our operators, and maybe even Richard can speak to this too, or Russ for that matter. One of our operators, Bill Lloyd, put together a fairly extensive report on his experiences after putting the system on his 182 RG, and I think he saw some airspeed increases. We certainly see airspeed increases. We expect airspeed increases in what I call slippery airplanes, airplanes that are designed to be aerodynamically smooth. So a 182 RG would be a real good example of that, a Bonanza, a Comanche, all those sorts of things. When we get into the world of, say, a 180 or a 185, I don't expect very much airspeed increases because they're just not designed for speed. They're designed for lifting and for being a truck. And of course, you know, when you put an Electroair system on your airplane, you immediately have better ramp appeal. You'll get to look 20 years younger than where you're at today. Funny when you say that to young people at Oshkosh, they're looking at you like, what are you talking about, 20 years younger? I'm like, yeah, well, 40 years for me in general aviation this year. So, Scott, go ahead and hit the next slide. Other things that we see typically are lower EGTs, lower TITs, for those of you running turbos. That comes from just doing a better job of getting the combustion event going inside of the combustion chamber where you want it. Most of the problems we have with EGTs or higher EGTs is because that combustion event is not completing inside of the combustion chamber, and you have unspent or burning plasma essentially coming out the tailpipe. That burning plasma is what erodes the valve seats and why we need to replace exhaust valves periodically. Better combustion also equals less blow by. There was a really good article in AOPA last month or the month before that Mike Bush wrote up, where he talked about the corrosive effects of blow-by, and that's a direct result of a poor combustion event. Better combustion event equals less blow-by, less corrosive stuff going down into the engine. Better leaning at high altitude. Again, because of the high energy spark, we will ignite just about any fuel air mixture you put in front of our spark plug shy of water and air. And even that, I'm not so sure we're not going to do something to water and air. But the ability to reduce or to lean further is a direct result of a high energy system. One of the questions that we get is, do you change your leaning techniques or your leaning practices? And obviously I get questions about, how do you feel about lean a peak? With regards to your leaning practices, I would tell you to do it the exact same way. You want to pull the mixture out to peak EGT. What you're going to find is that with the Electroair system, that peak EGT point occurs later in the pull of the mixture. So the leaner the fuel air mixture, we're still igniting that fuel air mixture off and getting it going and developing combustion, which is developing power. That's where we get the lower EGTs, the better leaning at higher altitudes. Really at any altitude, truthfully. The lean a peak question, I try very hard to stay away from that question, because I've always been a believer of that if you put 10 guys into a room to talk about lean a peak, you're going to get about 12 opinions. Where Electroair as an official position comes down is lean according to the engine manufacturer's manual. There's both rich a peak and lean a peak operations there, and follow those to the letter. I also, to touch on that subject, I'll touch on the cylinder head temperature issue too, because I think we see at Electroair, a lot of people go down rabbit trails as far as CHTs. There's a lot of commentary on the internet about what are really, where CHT should be, where they shouldn't be, that sort of thing. Your limit in the Lycoming engine is 500 degrees. And that CHT limit is set so that you don't start to enter into barrel head separation. Now we can start to talk about the metallurgy of aluminum and everything like that. I'm not promoting run the engines at 450, 460 degrees or anything of the sort. But there is a point at which CHTs can be too cold and the engine doesn't do a good job of lead scavenging. And that point's occurring down in the 320, 330 range. Most of these engines like to be operated at somewhere between 370 and 380 degrees Fahrenheit in CHTs ideally. That's the place that you're getting the best combustion, you're generating the amount of work you want for the combustion event, and you're also doing a very good job of lead scavenging. The other thing with regards to lead scavenging that we talk about with all of our installation centers is that when you're starting to obviously you can imagine the range of airplanes that we encounter and how many hours are on engines, how few hours are on engines. Frankly, the range of maintenance that's been done on the airplanes, all kinds of variables play into it. We have found and I encourage it within the 182 RG community, but really across the board, that before you put the system on, boroscope the engine, especially if you have a high time or a mid to high time engine, and see how much lead buildup is in the inside of the cylinders. This ignition system, as you elevate the CHTs and you get a better combustion event, it's going to begin lead scavenging that engine. And the plugs, if the engine is fairly leaded up, the plugs are going to follow right away, and you'll go through a cycle probably of about 10 hours or so of where you're pulling the plugs, cleaning them, putting them back in, running it, cleaning them, pulling them again, cleaning them, and so on until that lead gets itself worked out of the engine. Lycoming does have a pretty elaborate, it's almost kind of a crazy service instruction when you read it, and it's from back in the heady days of GA, which is 1983-ish, I would say, the early 80s, of where you can come up with a walnut blasting device, and you blast the inside of the cylinders with walnut shells.
Yep.
So that's interesting. And of course, reduce maintenance. The whether it's obvious or not, there are no 500-hour inspections on the Electroair systems, whether they be single or dual systems.
Come on, you can do it.
I think it hurts where she got.
There is, I lost my train of thought. You just don't have there's just nothing really to do. I mean, even at annual, there's nothing to check as far as timing goes because it's all controlled electronically. If you see timing drift, you're going to pick that up when you do an ignition check, and you're going to see your RPM drops change and that sort of thing. Go ahead, Scott, and hit the next slide. This is a little bit of a marketing slide.
Thought I just did. Nope.
So a high energy variably timed ignition system, like we say, it unleashes the power of your engine. All of these aircraft engines have a rated horsepower. That's what it's placarded with. But the minute you start putting accessories on the engine, like a magneto, as I mentioned, probably can reduce almost 2 horsepower off of what that rated engine is. Your alternator that's belt driven, all of these things that are taxing the engine, bring that rated horsepower number down from where it's placarded to wherever it's operating at. By going with an Electroair system, we now start to push that rated horsepower back up to what the placarded or the rated value is. Go ahead and hit the next slide, Scott. Which that's what I just said. By providing a tuned ignition system, we get you closer to the rated horsepower of the engine. That's where you notice the pickup in power and performance. Another thing that you would notice, or that we expect you noticed, would be just a better short takeoff or a takeoff run. When the very first airplane that we did the test flying on for a certified system was a Cessna Cardinal that flew out of a little grass strip in Michigan. It's 2,000 feet long, 80-foot trees at the south end, and power line right at the north end. And I mean, at the south end, those 80-foot trees were right at 2,001 feet. They were right there. The owner of the airplane, we installed the system on the airplane, and the owner of the airplane, who I didn't know as well as I did later on, but I knew was, he was a retired police officer. He's a Marine. And he was a paraplegic. And he looks at me after we get the system on. He had this Cardinal rigged out so he could fly the airplane. He looks at me, he says, "So you ready to go flying?" And I look at him and my eyes get a little big. I've never flown with Ron before. I'm like, he looked right at me and he says, "Your system, you better be ready to go flying." And I said, gulp, "Yeah, you're right. I better be ready to go flying." So we jump in this Cardinal and we do a power turn to take off to the south. And we rotate off, again, grass strip, we rotate off at an average day, nothing spectacular weather-wise, not a hot day by any stretch or anything like that. And we're climbing out, and we clear the trees at the end of the runway, and he looks at me and he says, "Wow, that was a kick in the seat of the pants." And I looked at him and I said, "Well, what are you talking about, Ron?" He says, "We rotated easily 100, 150 feet earlier than I ever do off of this field." And I can tell you that because I started flying out of that field in both the Cardinal and a 150, you know where you're rotating off out of that field, especially when you're going to the south, especially on a hot day. And I, kind of shrugged it off and said, I wouldn't know where you rotate off or anything like that. He looks me dead in the eye and he says, "Baloney, you were looking at those trees, weren't you?" And I says, "You're damn right I was looking at those trees the whole way." It's a sporty takeoff. So it does. The high energy tuned ignition system offers and this is where the high energy and the variable timing comes into play, is that engine gets up to power just that much faster. Scott, go ahead and hit the next slide. So I think for most of you, we're probably operating with the Bendix, the infamous Bendix single drive dual magneto. The picture here is of what the dual Electroair system consists of. So you've got 2 coil packs, the mag timing housing that replaces the dual mag on the back of the engine, a crank position wheel that goes up on the front of the engine, 2 wire harnesses, 2 controllers, spark plug wires, assorted hardware, that sort of thing. What's not pictured in here that generally goes with these kits is we really like you to replace that rotary key switch. In fact, I think on the dual systems, we mandate it. I personally hate rotary key switches. They are the bane of my existence. most of our troubleshooting, when we have a system where a customer calls up and says, oh, my ignition's kind of, it's running weird, it's cutting in, cutting out and everything else. Almost always our first question is, do you have a rotary key switch? And if the answer is yes, we ask them to disconnect the rotary key switch from the electronic ignition. 9 times out of 10, that takes care of the problem. You have to remember, a rotary key switch is a ground path switch that is normally open. So when you are moving from both and you put the key switch into the left position, you have now closed a switch path that we call grounding out the right-hand magneto. That ground path, what it's really doing is it's diverting the energy from that magneto to the ground post on the battery and away from the spark plug. When you go back to both, that ground path is now opened up. The magneto's been continuing to fire right along, so the energy it functions like a gate, if you will, and sends the energy back to the spark plug. In the case of an electronic ignition system, when you ground it out, as it were, you are effectively turning off the signal to the controller. The controller then doesn't see the signal and it says, I'm no longer going to fire plugs. So that's fine for turning off the ignition. Now, when you go to turn it back on, that ground pathway is removed. The signal is beginning to generate. The electronic ignition has to locate itself in the firing order before it'll begin firing. And this is true not just for the Electroair system. This is all electronic ignition systems. I haven't found one yet that doesn't have this issue. So by switching that rotary key switch to a toggle switch, or a rocker switch in our case, we force you as the pilot to slow down, shut one ignition off, see if there's a drop, turn it back on, let the engine recover, and then shut the other one back off. It gives you far more control over the engine and the ignition systems than what the key switch does. The other nice part about it is it gets rid of the AD node on the key switch. So that's one thing that's not pictured here. The other thing that's not pictured here, which is very common for most of these dual systems, is a backup battery system. When we went through the STC process, the requirement from the FAA was you had to be able to put backup power onto at least one of the ignition systems. You could do that a couple of different ways. You can do a backup alternator. And if you have a backup alternator on your airplane, we can certainly walk you through how to wire that in. It's pretty easy. But most of these airplanes don't have a backup alternator. I don't know, is there a backup alternator approved for the 182RG to replace the vacuum pump?
Supposedly, there's a shop out in Lynchburg that has an STC to put a backup alternator on. Okay,
so that becomes an option for you. B and C, if you want to go down that pathway, we actually have a DAR available to us that will work you through a field approval on their unit. He's been doing them on Moonies and he's been doing them on Cardinals. No reason why it can't be done on the 182 unless there's just no room.
I've never seen one in the field. They might be, allowable, but I've never seen one.
Again, there wasn't one up until about a year ago on a Cardinal. And now there's easily a half a dozen of them that have been completed. Same thing with the Mooney, the M20J and the 4-cylinder ones. There hadn't been any done in the field. I know Rick has done. His name is Rick Anderson. He's a retired FAA FSDO guy. He was the manager for the Detroit FSDO for a long time. And as a retirement gift, they gave him all 58 function codes for a DAR. So this is how he pays for his flying. Rick's a really good guy, but there's a way of doing it with a field approval. And I will tell you, given the state of the FAA today and some things that I'm seeing from my end, unfortunately, that's probably going to be the pathway that we have to go down. Anyway, the FAA requires some sort of backup power for at least one of the ignition systems. The most common way that we do it is with a TCW backup battery. They also required of us that we create a backup battery monitor panel, which again is not pictured in this picture, but that gives you that's monitoring the backup battery, gives you a voltmeter so you can see the condition of the backup battery. There is a annunciator light that comes on when when the backup battery shifts or locks out the primary aircraft bus and is running on the running one of the ignition systems on the backup battery and a couple of indicator lights for the ignition systems so that you know that they're on or not. That essentially comprises, I want to say it's about five or six STCs in there, because we end up doing a lot of STC authorization letters, but that gets you the entire package. We do have, go ahead, Scott, and if you want to hit the next slide, this is the last one. Darrell, conveniently enough, is having computer problems. He does have some special pricing set up for a year-end sale. His phone number and email are right there on the slide. Just go ahead and reach out to him and he can walk you through there's a questionnaire that we walk you through to be able to tailor a kit to your airplanes. So how'd I do, Scott? What was that about?
Good. We're doing pretty good time-wise.
So there you go. There's my presentation.
Great.
I am ready for questions. Or orders. I'll take orders.
Yeah.
No problem with that. I brought my order pad.
Yeah, I was going to say for our club members, I was going to say if you had a pre-assembled kit, I wonder if we might figure out some discounted situation for, I don't know, more than one person at a time or something.
That is a question for Darrell.
We can talk about that later.
We can talk about that later. If you send Darrell an email,
Okay.
I let him deal with all that stuff. I'm busy making parts, frankly.
Very good. Very good. All right, we'll open the floor for questions for whoever would like to. I've got a few if nobody else does, but
I got a question, Mike. So I'm in the middle of an install at the moment, and Mike, you and I have corresponded as well as Darrell. Thanks for all the help, and Buck Jordan. Just a note for the club: follow their advice when getting someone who's done this before. I used my existing A&P and had to stop work and get to somebody who has had more experience with it. But with that being said, Mike, what do you think are the biggest mistakes that we as owners should be looking at for when the install gets done, and how do we check it?
Wow. At the risk of throwing professional aircraft technicians under the bus, 95% of I'm going to even say it's 99% of the issues that we run into with systems come as a result of installation problems, one way or the other. Spark plug wires are a fairly consistent issue that we run into. It's important to have the spacing into it. Here's how I will approach it, because I had this conversation earlier today with a brand new A&P who's starting to install a system on an oddball experimental. It's when we were kids growing up and we built model airplanes, the first instruction in the model airplane instructions were read all the instructions first, right? Take an inventory of your parts and read all the instructions first. And most of us just bypassed that and started putting things together. In this case, I would really encourage you to read the instructions first. I know that the installation manual from the one that I wrote originally, 15 years ago now, which was probably at about 30 pages, just by creep, has gotten close to 100 pages with information in it. And it's crammed with a lot of information. There's no two ways around it. But I think so there's two things with that. Read the installation manual first, and then more importantly, come up with a plan. If you are working with your technician, chances are you're probably more familiar with your airplane than your technician is. And you also are going to deal with the aesthetic things that you want to work through on your airplane, like, for example, the switch panel. Where do I put the switch panel? Where do I put the backup battery panel? The installation itself is not meant to be difficult. We often say that this can be done by a competent A&P, but as you get into the installation and as you start to discover things that, hey, I could do this a little differently. Or, oh, I would really like to clean up this wire bundle that's in the back here, or remove all this junk that's been sitting here for the last 15 years that I forgot to do at my last avionics upgrade, or take your pick. The more of that stuff that you can think through in a plan ahead of time and really develop a task list for yourself and for your mechanic, the much easier and much smoother this is going to be. We often will tell people in during our installation center training, when we talk about the make a plan, is make that plan that you think is going to go in order, and then go approach your owner, your customer, and make sure he's on board with it, and include him or her as part of the process. This is your airplane. For most of us, an airplane is a very substantial investment into not only a transportation tool, but it's our hobby, it's our passion, it's all of those things. I will often call it's the legal mistress, or if there's women in our presence, it's the legal mister, that sort of thing. In fact, a funny story, my dad had a 150 and he called it Lola. My dad was a World War II guy, and he remembered a song that basically the refrain was, what Lola wants, Lola gets. And this little 150 got whatever she wanted. I'm here to tell you, because it was his hobby. So to circle all the way back around, I think where people get hung up on the installation is they don't do those initial steps, which sort of forces you to pay attention to detail and forces you to follow the steps and work your way through it. The other thing that I've seen this with shops, and I see Darrell now is live with us as well.
Can you see me now?
Yep.
I can see you now. We can see you now.
Live from Cristobal, Texas.
The shops will start ruminating on a problem with the installation, and they'll let themselves go 2 or 3 days before they give us a call and say, hey, wait a minute, do we really have to mount the coil this way, or can we mount it this way, or we really want to mount it this way, but does it have to be that way? For us, it's a 5-second conversation. And it's really important that whomever is doing the installation, you run into a problem, call. Generally speaking, we have already run into it. Heck, we might even have a picture to help clarify where the stuff can go.
It's a follow-up question. How do we inspect that the job's been done right, and how many hours do you imagine it would be for a dual install?
Question is, how do you inspect if the job's been done right, and how many hours do you expect it to take? So I'm going to answer the first question first, or the second question first. I don't know how many hours it would take. For a single system, Darrell and I have always used kind of a rule of thumb on a 4-cylinder single system, budget 2 days, the first day for sure, the second day to catch the things that you were going to run in, that you didn't know you were going to run into. 6-cylinder single system, budget 3 days, 2 days for sure, that third day to catch the things you didn't know you were going to run into. For a dual system, double it. So you could expect, I think, and Darrell, jump in here on this, I think it's fair to say on a dual system, you probably will have 40 to 50 man hours into it, because of, and just look at all of the things that you have to do that. You've got not only 2 electronic ignition systems, but you've got a switch panel. You've got a backup battery that's got to go in there. You've got a backup battery panel that's got to be wired in. Plus, don't forget the paperwork. There's, I got to sit and think about it, but I think there's about 6 STCs that have to be documented in your logbook.
There's 5.
Huh?
There's 5 STCs.
I think there's 6, Darrell. There's 2 airframe ignition STCs, the engine STC, the backup battery panel, and then the switch panel.
Yeah, 2 Electroair STCs for engine airframe on the systems.
3 Electroair STCs. You've got 2 airframe. Well, yeah, yeah. There's 2 separate kits.
It doesn't matter.
Authorization letter.
At the end of the day, it doesn't matter. It's a lot of STCs, and there is a lot of paperwork.
It's a lot of paperwork.
But it can be done all on 1337. That I have confirmed with multiple sources, including the FAA. You don't have to have.
And Buck, I forgot the first question.
The first was, how do we inspect after it's been
Oh
completed?
yeah, how do you inspect it? So really, how do you inspect it? Go fly it.
Yeah, put me there.
That's
Yeah.
going to be the biggest help.
Didn't say everyone.
Your first run up, you should be able to tell right away a difference in how the engines perform.
No, you can do messaging.
When you do an ignition check, bring it up to 1800 RPM, shut one side off, you may not notice a drop, no more than about 30 to 40 RPM drop. If you notice a rise, for example, which we do have happen occasionally in dual systems, now we got to go back and look at the timing. Something's off on the timing. I had mentioned before that we set the controllers up for the 182 RG. We back them off a degree. So the engines themselves are placarded for 23 degrees before we're top dead center. On the normally aspirated 182 RGs, we back that timing off to 22 degrees before top dead center. And then we also flatten the manifold pressure curve. Through, unfortunately, a lot of trial and error, we think we know a lot about engines, but we always get taught something new when we get onto a new airframe. These systems perform better when you've got dual Electroair systems. The flame front, as a result of combustion, moves faster, ever so slightly moves faster. And the peak pressure point of combustion, where we want it to occur at 16 degrees after top dead center, actually begins to occur at 13 to 14 degrees after top dead center if we were to leave the timing right at 23 degrees before top dead center. So I'm throwing a lot of science at it, but if we back the timing off by a degree, that peak pressure point now moves back closer to where we want it, which is 16 degrees after top dead center. The manifold pressure curve, again, we ran into some cylinder head temperature issues that just by simply flattening it out on the normally aspirated airplanes resolved that. You know, the cylinder head temperatures went up a little higher than we wanted to. For the turbocharged applications, again, on the 182 RGs, and we do this on a couple of the other dual system airplanes as well, we remove the manifold pressure curve out of it entirely. The manifold pressure curve doesn't come into play until you're 24 inches and below. And most of the time you're operating well above 24 inches anyway, so there's just no reason to have it in there. In fact, we did one here. I'll tell you how kind of problematic it can be. I just changed the timing today on a controller for a T210. And he said once he got above, the squawk was once he got above 10,000 feet, the cylinder head temperature started rising higher than what he would like them to be. And back and forth with the installation center, and this was one of our installation centers, I had him send me a picture of the controller so I could get the serial number off of it. The dust cover for the manifold pressure line was still on the controller. They never hooked up the manifold pressure line to the controller. The situation that creates, so this actually goes to your question about installation and attention to detail. The situation that creates is now without the manifold pressure line hooked up to the controller, the ignition controller is looking at ambient pressure and it's adjusting timing based on what's going on in the atmosphere. So as you're at 10,000 feet and you're in a turbocharged engine, you're probably boosted still to 28, 29 inches, but your outside air pressure is dropping below 24 inches. Now we're starting to advance timing, not when we want to, creating higher cylinder head temperatures. So to be frank with you, the problem probably never would have presented itself had he put the manifold pressure line on the nipple, but we elected to remove it anyway. So stuff like that.
Mike, one of the things that I would say about it, can you hear me?
Talk a little louder, Darrell.
I'll get the phone really close. One of the things I was going to say about inspecting an installation, as far as what you can visibly see, look for nice wire runs, especially your spark plug wires. It's imperative that we maintain good separation between the spark plug wires. We don't want them bundled together. Those are the kinds of things that you can look at. You can look at the sensor wires that are coming off the crankshaft trigger wheel and also the MTH. Make sure that those aren't tied into anything high voltage, i.e. a spark plug wire, battery cable, something like that. As far as the rest of the wiring, you probably don't want to crawl up underneath the panel and take a look at all that. That's a little difficult, especially for me. But some of the just attention to detail that you can see with the cowling off or opened up is wire runs. And if they've taken time to do that properly, the rest of the install is probably good as well. But Mike hit the nail on the head. When you fire these things up and you do your run up and you turn a system off, if you see more than a 40 RPM drop, that needs to be corrected. It should be somewhere around 10. When they're set up right, that's pretty close to what you're going to see. Anything, like I said, anything up to 40 RPM really doesn't require them to go back and look at timing. I hope
Can
that
everybody
helps.
hear Darrell okay?
Yeah, we can hear him.
Okay.
Good.
I can't, but I listen to him all day long, so it's just as well.
Well, I wish I could turn
Buck,
my
I'll
camera
throw
off
one
so
other
we
thing
can
in
see.
there to talk about just the installations, because I've had this conversation before about how do you pick a technician to work on your airplane, that sort of thing. I would encourage you to look at their hydraulic work. Are they using straight sticks of aluminum tubing? Are they using a tube bender to make nice 90-degree or 45-degree bends? I mean, you really want to get crazy with it if they're running a bunch of hydraulic lines parallel to each other that have unions. Are those unions staggered evenly down the line? It's if your technician is going through that kind of attention to detail on hydraulic lines, as opposed to, unreeling a big roll of aluminum tubing and straightening it out and, kind of butchering it in there, that's the guy you want working on your airplane. He's going to spend a little more time with it, but it's not that much more time to do it right and nice and neat and everything else.
Goodbye.
That installation will
Steve asked me a
last forever.
cryptic question whether Mario was working tomorrow.
Sorry, I'm muted. Go ahead, fellas.
What other questions we got?
Hey, Darrell. Or Mike, either one.
Hi, Richard.
Hey, Darrell. Is there any? I've since my installation, I've gotten everything. All the bugs are worked out. Everything's working great. Starts up like a champ, runs like a champ. I mean, it runs as good on one system as it did on that stupid DMAG.
As it should.
And if you turn the other one back on, it'll throw you back in the seat. Literally will throw you back in the seat. I've got a coil of control cable for the control box that's probably maybe 1.5 feet, 2 foot long. Any issues with me shortening that up? Getting Rusty to help me shorten that up?
Which cable is it, Richard?
Once the control boxes that come into the inside the cabin, I've got them coiled around the boxes to get it where they need to be, because where I put everything, I had some extra cable.
If Rusty helps you, I think we'll do it.
Okay.
I'm going to give you a two-part answer here to this, Richard.
Okay.
Yeah, I'm with Darrell. As long as Rusty's helping you, then I'd be okay with it. But are you just looking to? And look, guys, I can totally appreciate wanting to make these installations neat and making them look sharp and everything else. Originally, when we did this, we were going to send out wire harnesses that weren't terminated, under the expectation that the shop owner or the maintainer would have the right crimping tools and the insertion tools and all of the things necessary to make a good wire harness, and they could trim it to the way they wanted. Then I watched my engineer at the time try to assemble one of these without the right tool. I thought the bench was going to come off the ground. He's, shaking and pushing and everything else. And I looked at him and I said, Josh, well, you've just answered a big question for us, is that we're not going to send out a harness that's not terminated, because it becomes problematic. Richard, your airplane's flying really good right now, right?
Yeah, I'm inclined to just leave it alone.
I'm going to encourage you to do just that. Go fly it and enjoy yourself.
And if anybody wants to see my before and after numbers, I monitored fuel burn probably a year and a half prior to putting this in, and up until about a few months ago, I was monitoring fuel burn, and then I've just decided to stop. But I've got all that because, like Darrell and Mike said, yeah, we waited for the STC for quite a while, so I knew I was going to put this in, and I got some data before and after if anybody was interested in it.
Curious, what are you seeing gain wise?
Oh, hold on. Let me go back and look. Okay, so I used to fly around kind of usually 50% power, just kind of tool around, and I was burning an average of 10.4 gallons an hour. That's, just kind of tooling around. I found now that I'm running the Electroair in it, I'm more than likely going to run 2322. And I'm burning 9.5 gallons an hour. And, cruising about 150 indicated, 140 indicated, maybe depending on where I'm at.
Well, that's at 50%
What was
power.
that before,
What do you-
Richard?
what do you-
I probably run 75% power now.
Okay, so what are you getting at 75% power when you do it?
That's what I said, 9.5.
That low?
Yeah, you can run aggressively to peak and keep it around 320, 340, 375 on the CHTs.
How much brake horsepower? Like I fly that NDP 50 piece. I know, I've had the system for 2.5 years.
Mm-hmm.
Dual, and I love it, by the way. I make no mistake.
Thank you, Todd.
Hey, Darrell. We've talked a million times. I've never seen your face. You've never seen mine.
I know if I sit there and start running, Richard Peak, which after I talked to the Lycoming guys over at Oshkosh this year, I've gone back to running Richard Peak, and my fuel burn and running that is probably 11 and a half, maybe 12.
Okay, yeah, it's to be that. I would be like 50% power, the 9, 8.5, whatever it was. That the first comment seemed more accurate. But yeah, the earlier comment, I guess that was made about 40-ish install hours. That's 40 to 50. That's pretty spot on. I was one of the first ones to do it, so I had to kind of. There was no Electroair shop out there that had done a dual. I talked to several that had done signals, and one fella at signal said, "Oh, I got this down to a science. I do it 16 hours on a single." So yeah, you double it, and then you got to allow time for, like you guys said, the switch panel. My shop is I got a unique kind of shop. They're a training shop, but also a customer facing shop and a mission shop. So the director of my shop is a FAA DME. So we worked it out basically, and he said, "I'll charge you 40 hours." And I was like, "That sounds good to me." To install your dual system. That was in May of 2022. Excuse me, May of 23.
Yeah, so I guess I don't know who Mike, Darrell, who was number one on the R182s. I was either number one or number three or number two.
Well,
I'm going to let that one be Darrell because I don't know. Bill Lloyd was one of the first ones, I think.
Bill Lloyd was. Park Rapids installed one of the early dual systems, and literally have never heard from the customer again. I've asked Park Rapids about feedback, and they said the guy loves it and he just keeps on flying. An early one that was done was Mario Zambrano down in my neck of the woods. My other
gosh,
business
I forgot
partner.
about Mario. Yeah, for sure.
That was one of the early ones that we learned a whole lot on, especially the lead scavenging issue. Wow. that was
I think that's one thing that's probably true across the board of Electroair customers is that you guys fly your airplanes. and you fly them a lot. I mean, which is important. You're using the airplane as a time machine, which is what it's there for. I mean, that's why you have a 182 RG.
So
You
I've got
talk
another
about the
question.
you talk about the lead scavenge, and I remember the first 2 or 3 times I cleaned the plugs, I could even hear the lead tinkle out of the cylinders when I removed the lower plugs.
Yeah, it'll fall out in BBs. And that's why for these higher time engines, and it really is, it's more isolated to your group than any other dual mag group that we deal with. We don't see this nearly as bad on the PA32s because they're all injected. Well, most of them are. But these high time 182 RG engines are just so full of lead. And we know, or we knew that a single system, I've seen it in my own leaseback airplanes, will scavenge lead, but it does it over a slower period of time. The dual system, if you're loaded up with lead, it's going to clean it out really fast, as you learn, Richard.
Yeah, I can show you some spark plugs that'll just, and I tell everybody who's got a high time engine or a mid time engine that comes out of Rusty shop that I happen to talk to, stay in a pattern for a little while before you take off, just to make sure that you haven't got to clean your plugs because they get fouled up.
Yeah,
No,
I'll just quickly put my
absolutely.
2 cents in. I'll definitely verify that. Because that's the issue I had with my installation was that lead scavenging. It is impressive. I put mine on a high time engine. When I pulled the spark plugs out on the lower one, about half of the spark plug holes were half covered in lead. When you pulled them out, you looked in and they were half covered. So it's
So how many
impressive.
times did you have to do that? How many, like 2 or 3 times?
2 or 3 times. Yeah.
Yeah.
Yeah, until about that first 10 hours, as was mentioned before. I mean, the first time I should have done it after the first hour. If you know you have a high time engine with lots of lead, fly it for an hour, pull those spark plugs out immediately. Then I did it about again at 4 hours and then at 10.
And what are the preferred spark plugs? Is that the Tempest Platinum fine wire, or what do you guys suggest?
That's what I'm running.
I will tell you this. We've got it either way, whether you've got the turbocharged or non-turbocharged version, we've got a fine wire or a massive electrode plug available to you, Electroair plug, which is a Tempest manufactured plug manufactured to our specifications, which 2 main things. One, obviously the gap setting. We need a much larger gap in order to take advantage of the high voltage, long duration spark. And the other is they use a more robust seal internally on the ceramic to do a better job of handling our high voltage, which is 70,000 volts. I don't recommend for you 182 RG guys to go with fine wires if you have high time engines right out of the box, because you are going to deal with this lead scavenging, even if you do the walnut shell trick, which is awesome, by the way. And I heard you guys talking about that earlier. The problem that I've seen, and I had this happen to, and whoever it happened to may be on here. The mechanics ended up destroying 2 fine wire plugs trying to clean them, and they're very expensive, and that hurts when that happens. I recommend to most of our
I'm
customers.
responding back to some of the comments. I just noticed that they were coming up.
Yeah.
My recommendation is to go with massives initially and then convert to fine wire if you choose to down the road. Remember, these systems don't care what plug is in there. They're going to run fine on either plug. The advantage of the fine wire plugs being iridium, they're just going to last a lot longer. I have some plugs on my leaseback airplanes that have over 3,000 hours on them. So if you're flying a lot, it's something to consider. If you're a 100-hour or 50-hour year pilot, I'd stay with the massives personally. I hope that answers the question.
I'll tell you, the last annual we did, I just came at an annual about 3 or 4 weeks ago. We didn't even have to clean the plugs. They were that clean.
Wow. You'll be able to run that engine forever, Richard.
I'm hoping.
I hear you.
So I'm gonna about 5 hours, so probably not really mid time, I guess. But like, do you recommend us just pulling the plugs after the first flight and checking them, or how do you mitigate this? Yeah.
Yeah. It would. I can dig up those pictures, and it was impressive how much lead was in the plug.
If you could post them on that Type Club site, that'd be pretty cool. We have a thread going for this.
Hey, Buck.
Send me the link, Scott, and I'll put it up there. Put them up there.
All right.
Can you hear me? Can you hear me, Buck?
Gotcha.
Yeah, you're one of the things that I don't know if Mike mentioned it earlier, that is really a good tool to use prior to this installation is a simple bore scope inspection of your cylinders and see how much lead buildup you have. If it's significant, then you might want to try to do the walnut blasting to get the lion's share of that lead out of there prior to the installation. You're definitely, and I think Richard alluded to this earlier, that first flight, you don't want to go far. You want to stay within reasonable touch of your home base. And probably about a 30-minute flight is all you want to do. Get it back on the ground, pull bottom plugs, and see what you got. At the end of the day, yes, it's a pain in the butt, but getting the lead out of these cylinders is a good thing.
Yeah.
I mean, I can see the machine mark. I can see the machine marks on the top of the pistons now when I bore scope.
Wow.
Yeah, I don't have an R182. I'll work on them, but I have a T210 with a dual install system. It's a D turbo T210 with a 550 in it, and we installed it at 0 time on the motor at an engine overhaul, and we're at almost 400 hours now. You can still read the serial numbers on the top of the pistons.
Hey Chase, how you doing, buddy?
Doing good, Darrell. But yeah, you can still read the serial numbers on the top of the pistons. You can still read part numbers on the valve faces.
Yeah, do that with a sure.
Impressive. I think that also means much less likely to have sticky valves because you're getting such thorough burn.
Absolutely.
I don't have an engine monitor. That's always been kind of one of my concerns in the back of my head, at least. So with the increase of, well, I mean, I keep reading about the increase of CHT. At least that's what the Lloyd document says. Is not having an engine monitor problem right now for this?
Is not having an engine monitor what again?
I mean, I don't have an electronic engine monitor. I just get the factory, engine gauges.
Okay.
Is that a challenge, just given that we're kind of messing with the engine a little bit with the CHTs, or should I not be nervous about that?
I wouldn't be nervous about that. In fact, what I would do would be probably, okay, so the more information is the better, right? So at some point you may want to put an engine monitor in there. But you do have EGT monitoring capability. Are the old Cessna gauges, are they the single point EGT, or are they looking at each cylinder?
Single point.
Single point?
I think so.
But on each side, right? So one's on the left side, one's on the other side?
Yeah. Correct.
I didn't hear you, Buck.
Yeah, yes, that's correct.
Okay.
Do you have a normally aspirated or a?
So one of the things that you might want to look at when you're operating the airplane is keep an eye on the EGTs. Now remember, EGTs is a relative measure. There's not hard numbers there. We expect your EGTs to go down. And I think it's probably safe to say in a normally aspirated airplane that they'll drop about 100 degrees. That's typical. So if you don't see a drop, or if you see a rise in EGT, that means that cylinder or something on that side of the engine is not firing correctly, and it's dumping raw fuel down the tailpipe. If you see a huge decrease in EGTs, that might mean that the cylinder is running hot. A quick way to double check that, and again, I wouldn't worry about it once you get the system and get some time on it, but have one of those little IR thermometer gauges with you. And if you see that, when you land, pop the cowl and just check the temperatures of all of the cylinder heads. Now, they're not going to be what your operating cylinder head temps are normally, because you've landed the airplane, you've shut down, things are starting to cool off, right? But what you're looking for is a pattern. You're looking to see if one is sticking out hotter more so than the other, or if one is sticking out colder more so than the other. Both of those things are going to give you some insight. If you see the left side, when you land, let's say just to pick a number, and you hit the cylinder head temps with the IR thermometer, and they're all 400 degrees, there might be a timing problem with that. But a timing problem is also going to be picked up when you're doing an ignition check and you're looking at those RPM drops. If the timing is off, if it's too advanced, for example, during an ignition check, those RPM drops are now going to be creeping up well past 40 RPM. They'll be 60, 70, 100 RPM, more typical of what you would see with a magneto, versus if they're running right there, like Darrell said, anywhere between 10 and 30. Probably with a dual Electroair system on these engines, it's going to run a little closer to 30, just by the nature of the combustion chamber. I would say you're fine. The other thing you can do too, if you want just as an experiment, is get some heat tape, put it on the top of the cylinders, and the heat tape, generally speaking, will have a peak at where it's going to go to based on the color pattern on it. Run that a couple of times, and you'll see where your CHTs or where what your cylinders are seeing worst case scenario for temperatures. There's not a requirement with our system to run an engine monitor system, a formal engine monitor system like a JPI or a Garmin. They're nice things. They give you a lot of information. They help us a lot during troubleshooting. That's for sure. But there's other telltale signs of when you're running the engine that you can pick up on that'll tell you if it's timed wrong or if it's running hot, that kind of thing.
Thanks.
I had a question in the comment section about about massive versus fine wire. It came from Carlos, and he promotes using fine wire plugs with the turbocharged engines. I always tell people when it comes to picking the spark plug, let the engine do the talking. From an ignition guy's standpoint, the spark plug is really kind of the dumbest part of the whole system, because what it's doing is providing a gap by which we throw high energy spark across and ignite the fuel air mixture. But if I put my engine guy's hat on, you want to look at spark plug conditions. We've been talking about lead fouling on plugs and all that sort of thing. Very same thing. If they have a tendency to oil foul, more, and some engines do, more times than not, that's a good reason to go to a fine wire plug versus a massive electrode. The other thing too, the fine wire plugs, they've just gotten to be so expensive. It's if you're flying a lot, I don't remember if Darrell may have already piped in while I was typing back on some of the comments. If you're flying 300-400 hours a year, fine wire plugs are the way to go. If you're flying 20 hours a year, just stay with the massive electrode plugs. That's a big expense. What are they? Are they getting close to a couple $100 now for a fine wire plug? You're looking at what, 12 plugs, $2,400 for plugs. That's a lot of money. In my world, that's a lot of money.
Mine too.
Any other questions out there?
I got a few, but I want to leave room for anybody else.
Yeah, we're sort of going over on time here, so I guess we can stop the recording.
Scott, if nobody else has got questions, we've certainly, you've got the office number. You can get in touch with me. Certainly feel free to call up and ask questions. If I'm there, I'll do my best to take the call. Darrell's contact information, the email, that's his cell phone. I can tell you, though, the better way to get him, particularly this week, because he's off hunting and not working, or fan, is to shoot him a text.
I am working.
Darrell is very responsive to all that.
This is work right now.
I'm working right now. I could be out there with the rest of the guys around the campfire, but I'm not. I'm in here with you guys because I'm dedicated.
Darrell, cheers to you.
I'm drinking tea.
And by the way, you're right, it worked. So Darrell had to give me a little recommendation on some medicine I needed to take earlier tonight. So it's working.
Well,
Good.
I think I'm going to stop the recording because it's going to be a long one for people to rewatch, but we could keep going if you guys want to keep continued discussing.
We can. If anybody has any more questions, I'll be happy to answer.